Hello, my name is Rishi, and today I'm going to be going over this problem from the homework where I'm going to be proving why there does not exist a DFA for M. So we have for a string that's either zeros or ones, like anything in the alphabet, the language is essentially that, however, it has to be in this form. So let's assume first that it is like a string, like it is a language essentially. So let's say that assume that L is a language, and if L is a language, then we can say that some word exists in the language. So I guess for some K in the positive integers, so for like the states, so for some K in the positive integers, we can say that there is some string W, so string W equals 0 to the 2k, 1 times 0 to the 2k. And that essentially is a string in language, right? Okay, so for now, we're gonna like essentially one of the properties of the pumping lemma is that we can decompose this into so we can decompose it into W equals X, Y, Z. So we're gonna decompose it. Decompose into this guy. So how do we do this? So the properties that we know about the pumping lemma, or what the pumping lemma says, is that the xy has to be less than or equal to k, the size of it, and then y, the size of y, has to be greater than or equal to 1. So by that, we know that x and y have to be essentially like, so we can rewrite this as like w equals 0 to the k, 0 to the k, 1, 0 to the 2k, because if you think about it, it's the same thing, because k times is the same as 2k times. So because x and y are both less than or equal to k, or the length of it, sorry, then they're both going to be zeros, because there's k zeros. So we can say that x, let's say, equals like 0 to like alpha zeros, for example, and then y equals beta zeros, and then we know that beta is greater than or equal to 1, and that alpha plus beta is less than or equal to k. And then now we can find our z. So our z essentially is just going to be, it's going to be, so we're going to go back to this 2k. So we can say like 0 to the 2k minus alpha minus beta. Then we have our 1, and then we have 0 to the 2k, because it's just the rest of the string. And now we can say that, so now the next part of our proof, is to say that xy to the power of I times, or xy to the I, because you want to loop it, does not exist. So we're going to say, or essentially based on this information, we know that this should also be a language by the pumping lemma, because we assume that, that L is a language. So let's say xy I to the z. So that would be equal to 0 to the alpha, and then 0 I to the beta, or 0 like I beta, and then z, which is just 0 to k minus alpha minus beta 1, and then 0 to k, and then you can cross these out, and then you get xyi to the z equal to 0 I beta 0 to k minus beta 1 0 to k. And based on this information, we know that it has to be that has to be 2n. So we know that has to be 2n zeros. So by that fact, that we should know that ib plus 2k minus b should be equal to like 2k for this example, because that's the amount of states. So by this, we can say 2k is equal to ib plus 2k minus b. And then if we cross out 2k, we get 0 equals ib minus b. So therefore, if we just factor out like beta, we can say beta times I minus 1 equals 0. But let's say, for example, we use I equals 2. So let's just choose I equals 2. We have beta 2 minus 1 equals 0. But then you get beta is equal to 0, which is not possible, because beta, as we said before, has to be greater than or equal to 1. So we are met with a contradiction, and therefore there's no DFA M that exists. Cool. Thank you.